Hello, 6th graders. Welcome to Big Ideas Math, Section 1.6, Least Common Multiples lesson. Pause while you write Section 1.6 lesson in your math notebook. Pause while you write today's lesson objective in your interactive student notebook. Today's objective is, I can identify the least common multiple of two whole numbers by completing Big Ideas Math practice with 100% accuracy in multiple attempts. Today we're going to be going over the examples on pages 38 and 39 in your textbook. Yesterday you wrote the key vocabulary in your math notebook, so you don't need to write that again, but it does review it at the top of the page, so let's go over that. Multiples that are shared by two or more numbers are called common multiples. The least of the common multiples is called the least common multiple, or LCM. You can find the LCM of two or more numbers by listing multiples or using prime factors. Yesterday we went over the listing multiples, and today we're going to learn how to use prime factors to determine the LCM. Let's look at example 1. It says finding the LCM using lists of multiples. Find the LCM of 4 and 6. List the multiples of each number. Multiples of 4 are listed below. It has 4, 8, 12, 16, 20, 24, and so on. And multiples of 6 are 6, 12, 18, 24, 30, and so on. And it has directions to circle the common multiples, and the book has done that for you. And it says some common multiples of 4 and 6 are 12, 24, and 36. The least of these common multiples is 12. So they have circled that one in red for you. So, as I reminded you yesterday, this is exactly the opposite of finding the greatest common factor. Here you're looking for the least number. You're looking for the lowest one. Now let's look at example 2. So this is a new skill for you, so pay special attention and let me know if you have any questions. Find the LCM of 16 and 20. We're going to make a factor tree for each number. You know how to do that. And so here's your factor trees for 16 and 20. Write the prime factorization of each number. Circle each different factor where it appears the greater number of times. So if you look at the prime factorization for 16, it is 2 times 2 times 2 times 2. And when we look at the note off to the side, it says since 2 appears more often in this prime factorization, we circle the 2's. So they're circled in red. And if we look at the prime factorization for 20, it is 2 times 2 times 5. And 5 appears once, which is more often than it appears in the 16. So we don't circle the 2's again, but we circle the 5 because it appears more often there. And so we take these circled numbers and we multiply them together. And when we do that, we get 80. So the lowest common multiple or least common multiple of 16 and 20 is 80. In example 3 on the next page, we're going to be finding the LCM of 3 numbers. The numbers we're working with are 4, 15, and 18. Write the prime factorization of each number and circle each different factor where it appears the greatest number of times. So you need to be very accurate with your prime factorizations. So the prime factorization for 4 is written out for us, 2 times 2. The prime factorization for 15 is 3 times 5, and for 18 is 2 times 3 times 3. So if we look at our prime factorizations, 2 appears the most often here, so there's nowhere else where there's more than 2 2's, and 5 appears the most often in 15, so there's nowhere else where there's more than 1 5 or even 1 5, and 3 appears the most often in 18. There's nowhere else where there's more than 2 3s. So that's what those notes off to the side tell us. So we take our circled numbers and we multiply them together, and when we do that we get 180. 2 times 2 is 4, times 5 is 20, times 3 is 60, times 3 is 180. So we find the product of the circled factors. So the LCM of 4, 15, and 18 is 180. So that's a nice shortcut. It's much easier than listing out a whole lot of factors for all 3 of those numbers. Now let's take a look at example 4, a real-life application. A traffic light changes every 30 seconds. Another traffic light changes every 40 seconds. Both lights just changed. After how many minutes will both lights change at the same time again? Find the LCM of 30 and 40 by listing multiples of each number and circle the least common multiple. So we're back to listing multiples, and multiples of 30 are 30, 60, 90, 120, and to infinity and beyond. Multiples of 40 are 40, 80, 120, 160, to infinity and beyond. So now that we have our 120, we know we can stop. We know that's the least common multiple. So the least common multiple is 120. So both lights will change again after 120 seconds. Because there are 60 seconds in 1 minute, we have to be careful because it asked us after how many minutes will both lights change at the same time. So because there are 60 seconds in 1 minute, 120 divided by 60 equals 2 minutes in 120 seconds. Both lights will change at the same time again after 2 minutes. If you have questions about that, be sure and ask in class tomorrow or view the lesson again. To earn credit for viewing your flipped lesson, you need to complete your notes in your interactive student notebook, complete your on-your-own questions in your interactive student notebook and in your Google form, and complete your Big Ideas math assignment in your math notebook and submit that when it is 100% correct. Remember to visit your teacher if you have any questions.